In this video, we are going to discuss solve problem 5.2. The question says a massless spring located on a smooth horizontal surface is compressed by a force of 63.5 Newton, which results in a displacement of 4.35 centimeter from the initial equilibrium position. So you have a spring and you have compressed the spring by using a force of 63.5 Newton, and the compression from its initial equilibrium position is 4.35 centimeter. So my displacement x is 4.35 centimeter. I've written negative here because it is compression. When you convert centimeter to meter, you get negative 0.0435 meter. The conversion you make by dividing the number in centimeter by 100. Next, the question says a steel ball of mass 0.075 kilogram is then placed in front of the spring. So you take a steel ball and place it in front of the spring. They want you to find what is the speed of the steel ball when it is shot off by the spring. So when the spring is released and the steel ball is shot off, what is its final speed is what we need to find. To solve a question like this, we use conservation of energy, the law of conservation of energy. And to use the law of conservation of energy, we need to learn about the kinetic and potential energy of the system at different points. To calculate the potential energy of the spring, we need to know the spring constant K. Because potential energy of the spring is given by U equals half kx squared. And if I want to find this potential energy, I need to know what is K. So the first step in solving our problem would be to determine K. So step 1, I will write as first we need to find what is my spring constant K. Question has given me the force that we apply on the spring to compress it. And there is a relationship between force, spring constant, and the displacement the force produces. That relationship says F equals negative Kx, the Hooke's law. I will rearrange this term to calculate my K. We can rearrange and write this as K equals negative F over X. Now we substitute the value. F is 63.5 and my displacement is negative 0.0435. When you solve this, you should get your spring constant as 1459.8 Newton per meter. Once we get the value of spring constant, now we will use the law of conservation of energy to find my speed. So I'm going to write the step 2 here. Step 2 will be to find speed using law of conservation of energy. Law of conservation of energy says that energy at any 2 point over on a system, total energy at any 2 point must remain the same. So let's say I'm going to consider 2 points in my question. I will call this particular region as point 1 and this region as point 2. According to law of conservation of energy, total energy at 1 must be equal to total energy at 2. Total mechanical energy is nothing but sum of the kinetic plus potential energy. So kinetic plus potential energy at 1 must be equal to kinetic plus potential energy at 2. Now let us understand what kind of energy is present in each part. In position 1, my total energy is only the potential energy of the spring. Because the ball is not moving yet. The ball is not moving, its velocity is 0. So kinetic energy will be 0 here. But since the spring is compressed, you have potential energy of the spring. So U1 is present, but K1 is equal to 0. At point 2, the spring is no longer compressed, neither it is stretched. It is present at the equilibrium position. So potential energy of the spring at point 2 is 0. But since the ball is moving, there is kinetic energy because of the ball. So at point 2, you have kinetic energy present and potential energy of the spring is 0. So I'm going to substitute that knowledge here. We know for 1, K1 is 0 and for 2, U2 is 0. So when I substitute that, I am left with U1 equals K2. Now put their values. We know potential energy of the spring is half kx squared. So we write U1 as half kx squared equals kinetic energy is given as half mv squared. Cancel off the halves here. I want to find what is v, so we rearrange the term. I write this kx squared equals mv squared. We want to find v, so divide by m, kx squared by m. Then we take the square root on both sides to find v over m. Now substitute. V will be equal to square root k. So value of k is 1459.8 times x squared. So negative 0.0435 squared divided by the mass, which is 0.075. Now, if we substitute and calculate this, you get your answer for V as 6.06 meter per second, which you can round off to 6.1 meter per second.